Hello everyone, this is Alfio Sando. Today I'm going to cover PySpark Fundamentals and implement top 10 pattern. If you like the videos, you can support me by subscribing my channel and liking the video. You also can find the complete code and the complete video list in description below. Alright, so our first part is to understand what's the RDDs and how its roles in PySpark. So RDD is a data source, and these containers we can apply transformation on RDD, and we also can apply another actions on RDD. In general pipelines, we start with a list, then we can parallelize the list by store them into a different RDD. RDD also can be called as partitions. I will use this word later. There are several transformations are widely used. Filter, we transfer one RDD to another filter RDD, and we do the map, and we generate a new RDD, mapped RDD. Then lastly, we collect the RDD to our result, which is another action. Then what's the transformation? Transformation is used to create a new dataset from existing one. It uses lazy evaluation, which means we want a computer result right away. Instead, it will remember the transformations and apply eventually. So the advantage for lazy evaluation is it optimizes the required calculations. It also can helpful to cover from failures and for slow workers. Several widely used function for transformation operation, map. It will return a new RDD by passing each element of a previous RDD and run functions on those elements. Filter function will return a new RDD by selecting those elements of the source based on a function. And it also has distinct and flat map. Another type of transformation is based on a key. So once our elements are graded by a pair by key and value, thus we can use those key value transformation. For example, reduce by key will return a new RDD with the pair where the value of each key aggregate using the given function. Same thing as sort by key and group by key. Another important operation is called actions. Actions will cause Spark to execute recipe to transform source. So it's a mechanism for getting result out of Spark. Some widely used function for action, reduce, aggregate dataset elements using function. The function will take two arguments and return one. And this function's operation has to be commutative and associative, so it can be computed correctly in parallel. And it has take, collect, return all the elements as an array. Take order, return n elements, order in ascending order. Then the regular life cycle is as following. So user usually create RDD from external data. At the same time, parallelize a collection in your driver program. Secondly, lazily transforming them into new RDDs. The trick here, we can use cache to cache some RDDs for reuse, and those RDDs will save in the memory. Eventually, perform actions to execute parallel computing and produce result. All right, so I believe you have a basic understanding about PySpark transformation action. So next part, I'm going to implement those operations as a top 10 pattern. So what's a top 10 pattern? Top 10 pattern is a filter pattern basically to retrieve a relatively small number of top K records. Though it says it's top 10, so actually we can implement a way as the arbitrary K. One thing I have to remember that the K has to be a small number compared with the total number of records. Several known uses. To build outlier analysis, we can use top 10 to get a top 10 outlier, or like get a top K and the rest of them are outliers. In both ways, we can generate outliers. Select interesting data by getting the top K ranking, so we know which factor or which data are more interesting between all the data set. Catchy dashboards. We can create a dashboard by ranking the whole records, then to show the users what's the top 10s record in the dashboard. For simplifications here, I implement top 10 pattern as a simple problems by returning top 2 words that appeal the most. So later I will solve this problem by using two-step methodology. First methodology, I will doing the top 2 words in map site first. So this is used to decrease the bandwidth cost when communicating between map site and reduce site. To get the top 2 words in map site, we don't need to transfer all the words to the map site later, in that way to reduce the bandwidth. After we get all the top 2 words in each partitions or RDDs, we will run final top 2 operation on those top words to get a finally result in the due site. Okay, so then let's look at the data flow for this, for example. So here I start with a list of animal words. There's some distinct words and then some duplicate words. So at first I partition them into 2 partitions. So each partition we have 6 words. And I mean the yellow operation here means the operations happen on the map side, and blue operation happens on the reduce side. What we want to do first, as usual, we want to transform the word into a pair as the word as key name, and the value is the how many times it appears. We start with O as appear 1, then we do the group to aggregate the same keywords and counts. So here we can see the dog, the value becomes 3 because there's 3 dog pair here. Same thing on the partition 2. Then we do the first top 2 operations for each partitions. So here the dog 3 is the most appearance, cat 2 is second. The same thing here, we got pig 2 and dog 1. Then from the kind of 12 words in the map site, we reduce to the 4 words. Then we start to do reduce for those top 2 words. Then we will aggregate those 4, so dog become 4 because we aggregate these 3, dog 3 and with dog 1. Cat 2 and pig 2 are the same thing. Then in the reduce side, we do the top 2 operation again to get the final top 2, which is dog 4 and pig 2. So at first thought, it looks good in my methodologies. However, I found there is a drawback for this methodology, but I'm not sure it's really the natural drawback for this pattern or just doing some careless of my implementation. So the kind of reverse examples for these methodologies. Here I built another examples with 3 partitions, and each partition had cat 1 and other animals. So of course, doing the map side top 1 here, say this example, we only want to get top one. So we will output from doc2, maybe pick one or cat one, or line one or cat one. So eventually we will get doc2 in this case, or maybe cat two. But the really answer should be cat three, right? So if we aggregate cat one or from this partition, we get cat three. But we will never get that because this cat one in partition one, we will never output because doc2 is always greater than cat one. So I think, yeah, so this message, I think there is a few set of false positives appearance. It really depends on how robustness you want to your system to have. Okay, so to implement a previous methodology in PySpark, so here is my implementation. I start from the implementation of the animal list and tell the PySpark I want to have two partitions. So we can use rdd.glom.collect and to see what happens in each partition of rdd. So here it shows we separate the data into two partitions evenly with 6 words in each partitions. Then what we do is to run a map partitions given a customer functions. The reasons I'm using the map partition, not using previously mentioned map function is because our intermediate operation is kind of complicated. So maybe it's more readable or convenient to use a custom function and use map partitions to do the transformation. So in customize function, we first do the mapping as I showed in previous data flow slides. Then we will do the sorted of the mapping because later we are going to use group by function, and group by function needs sort pairs. So then this line and this line basically to do the group and aggregate the duplicate words counts. So after this, we got the keys to the count. Then what's the next? Next will be the top two in the map side function. So here we use a heap queue library to get the largest keys. Then eventually we'll output an iterator by using these generation patterns. Then here I'm printing out for what happens in each partition. Eventually we got the top two for each partition. So here for first partition we have 3 dog, so we get a 3 dog and 2 cat. Same for the second partition line. We have 2 pig here and 1 cat. Then we're going to start with the reduce side. We use reduce by key, so it's automatically doing group and aggregate. So we can see here cat 3 because it's group and aggregate this cat 2 and this cat 1. Also, dog 3 we still here and pig 2 here. Eventually, we will do in top 2 in the map side. Oh, sorry, in the reduce side. We got a cat 3 and dog 3, which is the final answer. Okay, so those are all the contents I want to talk today. Hopefully you like today's videos. See you next time.